We are working some calculus. We're under the section of evaluating limits analytically, and this is the button you need to click to see this kind of problem. Of course, I think there's like 9 different types of problems in this section, and they just kind of randomly come up. Alright, we got a piecewise function here. We're trying to find the limit. Actually, we will find the limit as x approaches 8 of h of x. Let's just move on into the classroom here. Let's erase the board and let's get started. We got the what's the name of our function again? H of x. That's what it was. H of x is equal to, of course, this is the more traditional way of writing that. And we have 2x minus 5. X is greater than 8, and then trying to remember, but I believe that last part was 11, and x is less than 8. We want to find the limit as x approaches 8 of h of x. Let me go back real quick and make sure that is exactly what we got. Okay, I was trying to remember. Alright, let me scramble up a graph over here. Okay, and we'll put 8, let's say right here. Good place. Now, what this says is we need to find this limit as x approaches 8 from the left hand side, and that means we're going to be using the bottom one here. Okay, and then we're going to find the limit as x approaches 8 from the right hand side, and that means we're going to be using this one. All x is greater than 8, 2x minus 5. Well, because this is less than 8, and this is going to be 11, let's just kind of sketch out here. So we're not going to include 8, so I put an open circle, and then it's just a horizontal line like that. Okay. Let's plug 8 into this. We get 16, and 16 minus 5 is 11. Does that sound right? Yeah. And we got a slope of 2, and we'll say it's something like that. Graph looks like. Okay, well, coming in from the left-hand side, which was going to be this one here, it's going to be 11. All right. Coming in from the right-hand side, you can see as we get closer and closer and closer, the graph is getting closer and closer to 11. Now, since coming in from the left is 11 and coming in from the right is 11, therefore we could say that the limit of h of x as x approaches 8, or however you want to say that, is equal to 11. But the question is this graph continuous? Well, let's check it out. First off, we need to find, and we're really just concerned about here. All right. First, we need to know what is h of 8. Well, because this is greater than 8 and less than 8, h of 8 doesn't exist. So I'm going to just state it as DNE here. Does not exist. So guess what? It fails right there. Because first off, this is one of the cases here where it has to be equal to a real number. Alright, and it's not equal to a real number, so therefore it fails. Even though this exists, okay, this exists, but that doesn't. Right, so part of continuity is that this must be one of the first things that must exist to a real number. Now, the reason we're concerned here at 8 is because this is a polynomial, and we know that this thing is continuous on the entire real number line. Once again, this is our domain here. So we know that everything to the right of 8, okay, that it's continuous. And this guy is a constant, right? We know that this line is continuous for everything less than 8. So the concern was what's going on here at 8, right?